na to ang first example for the design for flexure and shear for the mechanics of deformable pads. Okay, let's start for first problem. We have a rectangular beam of width B and height H, carries a central concentrated load P on a simply supported span of length L. Express the maximum shear stress in terms of maximum bending stress. Okay. So we have a given a beam. So ang beam na to is yung width na kuno is B. And then ang iya pong height is H. You have an height H there. Next is that not a simply supported span nga L. So we have a reaction 1 here. And then let's say itong reaction 2 sa Picas, we call that our reaction 2. Length niya is tawag na to L. So pa other given, so muna siya no, basta nga ni it's at times much better if i-draw na po nimo ang given para mas dali siya masabtan. Then ingon niya nga na daw kuno load, concentrated load P acting on, there is a central, so nasa tunga, concentrated load P. Unsa may next ani buhaton? So we have unsa kanina siya, we have the maximum shear stress for rectangular section, di ba? We have 3V over 2BD, if you remember. And then our maximum bending stress is equal to 6M over BD squared. If you notice, ang B ug D ato na ni siya makuha, but ang V ug ang M is di na to makuha. Ato lang makuha diri sa given nga graph or the given nga problem. So if we have a concentrated load P at the center, the expected by symmetry atong reaction 1 is katunga ni load P, so that is P over 2, and then the reaction 2 is also P over 2. So we can also draw our shear and moment diagram from this example. So we will have our shear diagram and then our moment diagram. Okay, since ato mong kaon ka ni si V, kani si V og si moment. So kani siya makuha na to if we cut the beam or if we draw the shear and moment diagram. For a shear diagram, so natay ni Saka diri, we have positive P over 2. And then paingon sa center, so nidagan na siya paingon sa center, P over 2. And then naay panaog nga P downwards. So paingon diri si P, that is negative P over 2. And then paingon sa right reaction, that is real constant or 0 degree. Then diri natin positive P over 2 pasaka. So this closes the shear diagram. So sa moment diagram, expected nga first degree nga line ang ma-present dira. Para makuha na to si moment is, that is just the area from the shear diagram. So itong area dira, that is just equal to length times width. So itong length diri, that is L over 2, because this is 1/2, that is L over 2, times the height nga P over 2. So itong moment, which is equal to the area from the shear diagram, so that is equal to PL over 4. So ato ding maximum moment is PL over 4. So take note for this one, our maximum shear is P over 2 and our maximum moment is PL over 4. Next, next ato buhaton. So we have here no our diagram para mas maklaro. So again, ato ang shear is, that is 3V over 2BD. And then our maximum bending is, for a rectangular section, is 6M over BD squared. So first, no, we already have determined that our maximum shear is equal to P over 2, and that also our maximum moment is PL over 4. So substituting the value for PL over as a moment, ato man daw i-express si FB or si shearing stress in terms of maximum bending stress. Wato isula si bending stress that is equal to 6m over BD squared is equal to 6 times PL over 4 over BD squared. This is equal to 3PL over 2BD squared. Now, unsa may pwede na to makita nga relationship ni bending stress related kay shear stress. If you notice na atay BD diri. So from this one, we can extract BD. So if you cross the BD pagawas, so di ba ana naman na BD, FB, or the maximum bending stress is equal to 3PL over 2BD times D. So we cross. So ang new na to nga itsura diri, we'll have that BD or just the area is equal to 3PL over 2 bending stress times the depth D. So kani si BD ato ni mga substitute dire para kay shear. Okay, so next na to buhaton is substitute na to kay shear. We have FV is equal to 3V. Ang V na to is P over 2 over 2 times ang atong BD is 3PL over 2 times bending stress times depth. So again, para sa mga balibog, para mas dali, ato na himon nga numerator times the reciprocal of the denominator. So times, ang reciprocal sa 2 is 1/2. Reciprocal sa 3PL over 2 FBD is 2 times bending stress times the depth D times over 3PL. So sa may pwede na ito may tabo 3, ang 3 makancel, 2 makancel. At sa may other, ang P also makancel. So atong remaining is that we have the shear stress is equal to, unsa na lang may remaining? We have the bending stress times D over 2L. So is this right? Yeah, FBD over 12, yes. And then atong D, yung depth is in terms of H. So ang atong final answer is that the maximum shearing stress in terms of the maximum bending stress is equal to the bending stress times the depth of the beam na H over 2L. So this will be our answer for this particular problem. So mo no atong gibuhat is giatagan-tag width ug height ni beam and then length ni beam also. As giignan ta giatagan-tag condition nga express ang maximum shearing stress in terms of maximum bending stress. And we know that the maximum shearing stress for a rectangle is equal to 3V over 2BD. So importante gid nung ma-memorize na ninyo. Instead nga magamit-gamit pa katong VQ over IB, taas na kay siya nga process. And then this is also rectangle. And then for the bending, that is 6M over BD squared. So mo rin to atong manipulate. Gidraw na to ang beam. We draw the shear diagram and also the moment diagram. So natay maximum shear nga P over 2 and then ang to maximum moment is PL over 4. So ato anang kuan kay this will be the unknown man V and M. So from the bending stress, si moment, gisubstitutan na to PL over 4. Tapos, yes. And then we come up ng ang relationship ni shear to BD is ang area niya, which is B base times the height. So mo ni siya si BD. Kani diri. So kani si BD is equal to 3PL over 2 times bending stress times D. Gisubstitute na to na kang kuan, shearing stress. And then we come up with the final answer, yung relationship ni shearing stress, maximum shearing stress to maximum bending stress for rectangular section for a concentrated load P at the center.